Question number 96. Members of kingdom Monera which do not have cell wall are: first option halophiles, second PPLO, third Anabina, fourth photolithotrophs. So the members of kingdom Monera means they are prokaryotes. They do not have cell wall. First is halophiles. Halophiles are archaeobacteria, and as the name indicates, halo means salt, philes means loving. They are salt-loving bacteria. They have cell wall. So this option is ruled out. Anabina, it's a cyanobacterium. It also has a cell wall. So this option is also ruled out. Photolithotrophs, they are photoautotrophic organisms. They can belong to any group of bacteria which are photosynthetic. So this option is also ruled out. Last is PPLO, which stands for pleuropneumonia-like organisms or mycoplasma. Mycoplasma are the smallest monerans and they lack cell wall also. So the organisms which do not have cell wall are PPLO. So the correct option for the given question is option number 2. Let's move on to the next question. Question number 97. Organisms responsible for causing red tide are also characterized by: first option, presence of stiff cellulosic plates. Second, presence of nitrogen fixing heterocyst. Third, presence of 2 longitudinal flagella. Fourth, filamentous body made up of trichomes. See students here, the organisms which cause red tide are dinoflagellates. Your teacher must have taught you about dinoflagellates, that these are photosynthetic organisms, single-celled organisms, belong to the kingdom Protista, hence they are protists. Fourth statement says that filamentous body made up of trichomes. No, dinoflagellates are single-celled organisms. Third one, presence of 2 longitudinal flagella. No doubt in that dinoflagellates are biflagellated. They have 2 flagella, but these flagella are not longitudinal. One of them is longitudinal and one of them is transverse. So this option is also ruled out. Second, presence of nitrogen fixing heterocyst. It's a feature of cyanobacteria, not the dinoflagellates. Some cyanobacteria have nitrogen fixing specialized cell called the heterocyst. So this option is also ruled out for dinoflagellates. First is presence of stiff cellulosic plates. Yes, they have stiff cellulosic plates on the outer side of the cell wall. So the correct option for the given question is option number 1. Let's move on to the next question. Question number 98. Ciliated protozoans differ from amoeboid and flagellated protozoans in having: first option, locomotory structure. Second, single-celled body. Third, heterotrophic mode of nutrition. Fourth, definite regions of ingestion and egestion. If you have seen the paper of NEET 2018, you must have seen this type of question in that paper. So this is very important question from your examination point of view. Ciliated protozoans. If you remember the example of ciliated protozoan, it is Paramecium. Amoeboid protozoans, amoeba, and flagellated protozoans, Trypanosoma. So now you can relate better. How ciliated protozoans differ from amoeboid as well as flagellated protozoans? First option, in having locomotory structure, no. Ciliated protozoans have cilia, whereas amoeboid have pseudopodia, and flagellated protozoans, as the name indicates, they have flagella. So in having locomotor structure, no. Second, single-celled body. All of them are unicellular as they belong to kingdom Protista. So all have single-celled body. So this option is also ruled out. Third, heterotrophic mode of nutrition. All of them are heterotrophic in nature. So this option is also ruled out. Fourth, definite regions of ingestion and egestion. Yes, ciliated protozoans such as Paramecium, they have definite regions of ingestion and egestion. It is the special features of ciliated protozoans which is not found in amoeboid and flagellated protozoans. So the correct option for the given question is option number 4. Let's move on to the next question. Question number 99. Under favorable conditions, slime molds form A, while under unfavorable conditions they form B. Complete the above statement by choosing the correct option for A and B. First option, fruiting bodies spores. Second, plasmodium fruiting bodies. Third, fruiting bodies plasmodium. Fourth, spores plasmodium. These slime molds, they are heterotrophic in nature, they are protects, and under favorable conditions, they just creep over the dead and decaying matter, enlarge their size and form the plasmodium. So under favorable conditions, slime molds form plasmodium. So A goes for plasmodium, this is correct. And under unfavorable conditions, they want to reproduce, hence they form the fruiting bodies. So B is fruiting bodies. So the correct option for the given question is option number 2. Let's move on to the next question. Question number 100. Continuity of cytoplasm of the adjoining cells in most of the club fungi is maintained by first option, simple central pore septum. Second, dolipo septum. Third, dissolution of septal walls. Fourth, chitinous cell wall. What are club fungi? Club fungi are basidiomycetes. So, in most of the basidiomycetes, the continuity of the cytoplasm of the adjoining cells is maintained by the members of the basidiomycetes. They have septate mycelium, and the septate mycelium have a pore called dolipore. So the continuity is maintained by the dolipore. Why it is written as the most of the fungi? Because in case of Puccinia and Ostelago, they don't have dolipore septa. They lack dolipore septa. So simple central pore septum, it is a feature of ascomycetes, hence this option is ruled out. Dolipo septum, yes, it is correct. Dissolution of the septal wall, no. Chitinous cell wall, no. So the correct option for the given question is option number 2. Let's move on to the next question.